Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this Peavey Xr-600F mixer. Now, according to the owner of this unit was working normally, and when the user or the owner he turned it off and tried to turn it on again, the unit did not work at all and did not make any kind of sound. Now, he tested the speakers. They were connected to the unit on a different unit, and the speakers work fine. So he contacted me in order so I can take a look at it, and as we can see, I already open it in order so I can repair it. Now, to be honest, I wasn't going to make a video about this because these type of mixers, they are very simple. But this unit in particularly, it has a really curious problem. Now, if I just remove the front control a little bit, and this thing, it is really stuck in its place. Okay, here we go. Now, taking a look at the back, we can see that here is the amplifier section, and it is dirty as hell, and there is some corrosion in here, and that is because of the dirt and moisture. Now, as I said, taking a look at the amplifier section, I noticed that this amplifier, it has a leaky voltage, or a leaky voltage in the speaker terminals. And also I noticed that there is a burn spot in here, and if I just zoom in a little bit, I can show you the burned spot. Now, behind this burn, there is a resistor and a capacitor. So these two components, they are part of the filtering of the speaker output. Also, the test shows that two of the transistors, they were a little bit leaky, and they were producing a little bit of voltage, or abnormal voltages, or abnormal voltage, if we compare it to this side. Now, this side was working normally, so what I did, I lowered the voltage in this side in order so I can just make the two amplifier work, in order so I can test the unit. Now, when I did this, I was able to get a sound from this circuit as a power amplifier. But the preamp circuit in this unit, it did not produce any kind of signal. Now, there isn't any kind or visible kind of burned or blown component, and that is really interesting. But there is a lot of dirt and dust on the terminals. So today in this video, I'm going to tear this unit down, and in order so I can see what's wrong with it and how I can repair it. So let's get started. Now, the first test in the repairing process, it was checking the voltages of the op amp, in order so I can see if there is the correct voltages are getting to the op amp ICs or not. Now, usually all of these ICs, as we can see, all of these SMD ICs, they work on the plus and minus voltages. The recommended voltages is plus and minus 15 volt. Now, if we get 15 volt or a 16 volts, it is okay. So this IC, as we can see, if we check this pin in here, we are getting 14.8 or 85, and that is close to 14.9, and that is really good for the negative side. Let's check the positive one and see what kind of voltages we are going to get. I'm going to check it in this capacitor, and it is, because it is connected to the positive, and as we can see it is 15.1, and that is okay. So the voltages are within spec. Now I'm going to feed the signal to this to the input of the tape, in order so I can see if I'm getting a signal out through the input signal of the amplifier section. Now, as I said earlier, I rigged the amplifier of this section in order so I can just test it. If it is test the signal lines in it. It doesn't matter if it worked correctly or not at this point. The only purpose is just so I can see if the signal it is coming out of the speaker terminals or not. So yeah, let me just pause this and connect the oscilloscope and see what it is happening. So here is the oscilloscope, it is connected, and if we take a look at the input of the tape input of this unit, we can see that here is the signal generator signal, as we can see in these terminals in here, and in the output of this op amp we can see that in this terminal in here, that there is no, and here we have the signal in the output of this pin. We have also the signal. Let's check, and in here we have also the signal. So the signal it is passing from this op amp to the board. So the tape amplification op amp circuit, it is working normally. Let me check the other op amp in order so I can see which one it doesn't make the amplification, and take a look at the schematic, and then I will be back. Now, as we can see, when I connected the signal generator to the tape input and I boost up the signal level by the controls, we can see that we started hearing some noise or some sine wave noise from the speaker that I connected to this amplifier. However, when I started checking all of the op amp amplification signal, I found that the op amp or amplification signal in this IC in here, this is pin 1. As we can see, this signal it is very strong. In the pin 7 of the same IC, we can see that the amplification it is way more higher. So yeah, so this IC it is working, and I started probing all of these op amp, and these are for the equalizer, and I stumbled on this IC in here. Now, taking a look at this IC in here, we can see that there is a problem in this IC in particular. So what I'm going to do, I'm going to change this IC in order so I can see what if the signal it is going to change. Now, taking a look at the IC itself, we can see that there is a burn spot in this terminal, and this is the VCC terminal. So this tells me that this IC it is probably faulty. Yeah, if we probe the pin 1 of it, we can see that the amplification it is very weak. So yeah, So I'm going to change this in order so I can see if the situation it is going to change or not. But I believe I found the culprit. So yeah. Wow. It is definitely faulty. So here is the new IC. It is installed and soldered into its place, and here is the old one. Now, taking a look at the old IC, we can see that it is completely burned up, and there is the only way that for an IC to get burned like this is to get an electric shock above the recommended voltages. So yeah. So now what I'm going to do, I'm going to turn on the unit, connect the oscilloscope in order so I can see what kind of signal that this new op amp it is going to produce. So here's the unit has been turned on, and I already connected the probes of my oscilloscope in order so I can test the signals that this new op amp it is going to produce. So here we go. Now according to the pins, here is the pin 1, 2, 3, 4, and this is 5, 6, 7, and 8. Now in these op amp, the 8 and the 4, they are the VCC plus and minus. Let's test the pin 5 of it. This is usually the plus input. As we can see, we have this signal on pin 5 of it. In pin 7, this is the output of this op amp, and as we can see, here is the signal that it is producing by the op amp. Let's test the other section of the op amp. Now pin 3, it is usually the input. Let's probe it correctly. We have a signal, but oh, here we go. And here is the output of the other op amp. We can see that it is really strong. Now that is really good. So yeah. Now this tells me that the new op amp it is working and working correctly. What I'm going to do now, I'm going to connect the speaker in order so we can see what kind of signal that the amplifier it is going to produce. So I connected the speaker to the left amplifier of the unit in order so I can see if there is any distortion in the output of it. And now I'm going to boost up the main volume in order so I can see what kind of signal that this unit it is going to produce. As we can see, we have a strong signal, but there is a huge humming. Now the humming usually wow. The signal it is strong, but there is a huge humming. Now the humming usually is from the filter capacitors, or there is a problem in the amplification circuit or in the preamp circuitry. So I'm going to take a look at these two sections in order so I can determine what causes this humming. So yeah. So I tested the filter capacitors in the main amplifier PC board, and it turns out that the two capacitors they are gone. Now as we can see, this one it is a little bit bulged as we can see, and this one it is more bulged. Now I tested these two using the capacitor meter, and the test shows that this one, as I remember, give give a value around 7,000 microfarad, but this one give a value around 6,000 microfarad, and from the original value that it is around 10,000 microfarad. So the two filter capacitors, they are gone. Also, I replaced the two transistors that I rigged earlier in order so I can bring the this channel to a full operation condition. Also, I remove this PC board from its place in order so I can replace the burned resistor in here. And it turns out that the original resistor, it is a 22 ohm 1 watt, and the capacitor, it is a 100 nanofarad. So yeah. Now, while I was watching and tinkering with this board, I found that there is a 6mm jack head. It is stuck in this jack in here. So yeah, as we can see. So what I'm going to do now, I'm going to remove and desolder this jack from its place in order so I can remove this tip. So after I repaired the amplifier section, I moved to the preamp section in order so I can continue the testing of the other op-amp, and the test shows that there is 3 other op-amp. They are not working well, so I replaced them with brand new ones. After the new op-amp, they are installed and soldered into their places. I reassembled the entire thing and connected it to my test gears, and the test shows that everything, it is back into a full working condition. So this mixer, it is now fully repaired and it is ready to be delivered to the owner. In the end, I hope that you enjoyed this short video. Please like, subscribe. Thank you for watching. See you next time.